Page 732, lesson 12.2 is on frequency tables and histograms. So frequency tables we've looked at a little bit before. So a little bit of terminology first. Frequency is the number of data values in an interval. Basically, it's like how many times something happens. And a frequency table groups a set of data values into intervals and shows the frequency for each interval. On a frequency table, the intervals don't overlap, don't have any gaps, and are usually equal size. One thing to keep in mind when you do frequency tables is we are not going to skip numbers even if the frequency is 0. Okay? Even if there's no numbers that happen in an interval, for example, we're not going to skip that interval. We're just going to still put the interval, just we wouldn't have any tally marks we'll talk about in a minute. And then we would have a frequency of 0. That helps us to see that we do have a gap. We do have a section where there isn't anything. If you just skip it, then we can't see that as well. So if we look at problem 1, we are going to make a frequency table. They have numbers of home runs by batters in a local home run derby are listed below. What's the frequency table that represents the data? So when we make a frequency table, we need to decide some things ahead of time. We're not just going to blindly just throw numbers at the table and see what happens. So it talks about over here planning how to choose intervals. So first thing, if you're making a frequency table, look for the lowest and highest numbers. In this case, 2 is the lowest number, 17 is the highest number. And that's actually 16 possible values. And you might say, well, how do you get 16 out of that? Well, if you subtract those is 15 and then add 1, that tells you it's 16 numbers. And you might say, well, why do we add 1? Well, let's think about if we have 1 to 3. From 1 to 3, you know that's 3 numbers, right? 1 to 3 is 3 numbers. If you do 3 minus 1 is 2. Okay, so it always works if you subtract but then add 1. That'll tell you how many numbers you have all together. Okay, so we have 16 possible values. What we're going to try to do, we're going to try to split that up. So 16 is a pretty nice number. If it's not a nice number, I'll expand it a little bit. I'll make it a little bit bigger, okay? Like if I had 13, 13's not a good number to split up. So 13, I might expand that to like 15 or 16, okay? It's got to be expanded. We can't shrink it down because we've got to include all these values. When we're doing these frequency tables, we're going to try to have 3 to 5 groups of numbers. Okay, we're going to try to have 3 to 5 groups of numbers. 3 to 5, 3 groups, 4 groups, 5 groups. That's just a pretty nice number to where we have stuff split up a little bit where we can make some interpretations about what's happening, but yet it's not like so much. If we spread it out too much, then it's really not telling us, I don't want to just know how many times did somebody hit that exact number of home runs. We're just doing intervals. We're just looking how many hit between this many and this many home runs, okay? And then also, if we had like 16 different groups, that'd be a lot of stuff. You'd be using like half a sheet of paper for every problem. So those are a couple of reasons why we're not going to do it that way. So you can see then what the book did. Basically, if you do 16 divided by 4, we had 16 possible numbers. If we divide it into 4 groups, that would be 4 numbers per group. And that's what they did here in your book. So they had, the first group was 2 through 5, 2, 3, 4, 5. That's 4 numbers. And then we pick up the next right where that left off, 6, 7, 8, 9, and then 10, 11, 12, 13, and then 14, 15, 16, 17. The nice thing when you do these is if you're going by 4s, you can actually add 4 to each number on the left side, and you can add 4 to each number on the right side. Okay, obviously the next number is just going to pick up right where the other one left off, but that's a good way of checking if you've split that up correctly. And then a lot of times in these frequency tables, there would be a tally column in the middle. And then that would allow us, as we're looking through the numbers, we can make tally marks and keep track of how many we've got. So we could say, I've got a 7, I've got a 17. Okay, we're looking at what group it would go in. 14, I've got a 2. Okay, and we just do tally marks for all those, and then it should end up apparently looking like this. Okay, remember for tally marks, when you get to 5, you can cross over, and then it makes it easier to count up your numbers. So if you look at the got it, it says what is a frequency table for the data in problem 1 that uses intervals of 5. So we went by 4s. They're saying what happens if we would go by 5s instead? Well, the deal is we had 16 possible numbers. So if I'm going to try to go by 5s, 16 isn't divisible by 5. That's not going to work. And we can't go lower. We can't say, oh, 16, that's close to 15. I'll just make 15 possible numbers. Because if we go to 15, either the 2 is going to get left out or the 17 is going to get left out of our table. We've got to expand it then. So we're going to think about the next possible multiple of 5. And that would be 20. So we're gonna jump this up to 20. Okay, so if we have 20 possible numbers, and they said we're going to go by intervals of 5, so if we do 20 divided by 5 would be 4. So that tells me we were going to have 4 groups of 5. One other thing I didn't mention on the frequency table, they had a title there, home run results, and then they had a home runs listed as well. So I'm not going to put the title here, but you should have something on your frequency table that tells us what it's talking about. Since we expanded this, we actually only have 16 numbers. We expanded it to 20. That means we're possibly going to be starting at a lower number or ending at a higher number or both. So if we say maybe we're going to start at 1 instead of 2, 2 is actually the lowest home runs anybody got. But let's say we're going to start with 1. We're going by 5. So 1, 2, 3, 4, 5, just to double check. So we're going from 1 to 5. Our next group's going to start where that left off. So we're going to pick up where that left off. So we're going to go from 6 to 10. The next group would be from 11 to 15. And then finally should be our last group is going from 16 to 20. Okay, and again, on the nice thing by us starting at 1 is these ending numbers are all multiples of 5. But like I said earlier, if you just add 5 going down to the next number below it, that should work out if we're going by intervals of 5. So at this point, it's going to be a matter of looking back at those numbers and seeing how many we're going to have in each group. And that's up to you how you want to do that. If you want to, you can just pick out all the numbers that are in a certain group. Another way of doing it is just starting with the first number. So like 7 goes in this group. And you can just cross them off as you go if you want, or you can just keep track of where you're at. Obviously, if this is in your textbook, then you're not going to probably want to cross them off in your textbook, but if it was on a test, you could do that if you wanted. And then once we get done with that, we're just going to look at how many tallies we have in each group, in each interval. So I've come up with 4, 5, 4, and 1. Okay, and then we could do interpretations off of this. We could say more people hit between 6 to 10 home runs than any other interval. Or we could say the same number of people hit 1 to 5 home runs as the number that hit 11 to 15 home runs. Okay, different ways we could analyze what's happening here. So the next thing we're going to look at is histograms. Histogram is basically a type of bar graph. It's a bar graph that uses numbers. So instead of like, what's your favorite color? With a histogram, we wouldn't be talking about something like that. We're talking about something that involves numbers, something that maybe involves intervals of numbers. And one of the things with histograms that's a little different than what we might do for bar graphs sometimes is there's no gaps between the bars. Also, there's no gap between the first bar and the y-axis. It starts right next to the y-axis for the histogram. So to start with, for doing a histogram, we are actually going to generally make a frequency table. We're going to make a frequency table, and then that's going to help us to know what our histogram is going to look like. So if you look at problem 2, they have hours per week a group of students spent watching television, and they're asking us to make a histogram to represent the data. So the first thing that I would do is look for the low and high numbers out of the group. So the lowest number is 0. Highest number is 22. Okay, so that's going to give us an idea of how we're going to go here. So we've got from 0 to 22. Remember, if you subtract those as 22 plus 1, we actually have 23 numbers. 23 is a prime number, so that's not a very nice number to work with. So one option would be if we just add one more into that, it would give us 24 numbers. 24 divides by 4 evenly, so that's in fact what the book is doing. They're splitting this, going with 24 numbers total. They're just expanding this by 1. Obviously, we're not going to expand any lower than 0. We're still going to start at 0. We can't have -1 hours of TV. But they'll just expand it up to 23 instead of 22. And that's what they did there. Again, they actually went by sixes. They went with 4 groups of 6. And again, mentally it doesn't seem like it is, but 0 to 5, your brain thinks maybe 5 numbers. 0, 1, 2, 3, 4, 5. It's actually 6 numbers, okay? So 0 to 5, 6 to 11, 12 to 17, and 18 to 23. That, again, puts us in intervals of 6. Okay, 6 numbers in each group. And then we're just doing the tallies for how many times we see it happen. And then you can see the frequencies are there. I know you guys are capable of counting, tallying numbers and writing how many tally marks you have, so we won't go through that process anymore. Once we get that, then we're going to make our histogram. For the histogram, it should be pretty complete. We need to have a title that tells what's happening. So they said watching television. And then we need to label the x-axis and the y-axis. Y-axis should always be frequency for what we're doing in this section. In this case, we're talking about how many hours. So hours is going to be on our x-axis. And then they just went by twos. If you were doing this in your notebook, this would be where you would maybe have lines here that you could kind of still see. You don't have to go crazy shading your bars in or anything, okay? You can make it to where you can still see your lines. You know, you can just kind of go like this if you want. If you want to shade the one next to it a different direction, make little patterns or something, you can do that, whatever, okay? Anyway, just make sure your frequency goes up at least high enough to get your highest frequency on your table. If you want to go a little bit beyond that, you're welcome to do that, but make sure it at least fits all of your numbers there. So look at the got it 2. The finishing times in seconds for a race are shown below. What is a histogram that represents the data? So we're going to go through the whole process here, start to finish, of creating this histogram. So first we're going to look for the lowest and highest numbers here. The lowest number is 80 and the highest number is 105. Okay, make sure you take time that you actually are finding the lowest and highest numbers, because if you find out after you set it up that you don't have all the numbers in there, you're going to have to start back from scratch. Okay, so 80 to 105, if you subtract those, doesn't look too bad as 25, but remember we have to add 1 to that. So we actually have 26 numbers. 26 is not real great of a number to split up. If you want to with these, working with multiples of 5 doesn't work too bad usually if you want to go that route. So if we just expand this a little bit to 30, that's going to be a little bit easier for us to split up. And what we can do, if you want, we can split that just up into 3 groups. We can split it into 3 groups of 10. Obviously, there's other ways that this could be done. You want to have at least 3 groups, okay? I mentioned earlier trying to have 3 to 5 groups. If you only have 2 groups, then that really doesn't split things up very well to tell you what's going on. Okay, so we're going to go by 3 groups of 10. On this one, since the frequency table isn't like our final thing that we're doing, you don't have to be super detailed on your frequency table. Okay, so our lowest time was 80. 80 is a pretty nice number to start with, so I'm just going to keep that the same. If we're going by tens, we got to think about where that's going to end. 89, and then the next one would start at 90 and go to 99, and then we could go 100 to 109. Okay. Another option we could have done, instead of going to expand this to be 30, you could have just expanded by 1 more and it would have been 27. You could have done 3 groups of 9 with 27, would have worked also, just as another example. Okay, and then now we're just doing tally marks. So we'll just look 95, 105. Okay, just mark which interval these would be in. And this is kind of nice because it's basically just dependent on our tens value or if it's in the hundreds. All right, so once we've done that, we are going to make our histogram based off of that information. if you want to, when you do these, you can use graph paper or just regular paper in your book. Should work fine. Just doing graph paper here so I can kind of keep track of my lines. So frequency goes up to 6. This is the finishing, we'd say race finishing times or something like that. So this is the time in seconds. Make sure you leave room for your intervals down there. One thing a little different on this one is that, unlike the one in the book that started at 0, our first number starts at 80. So we're going to do a little break along the x-axis. Okay, so I just did this little kind of squiggly line here. That's showing a break because I'm not starting at 0. And so that would be the only case where we're not going to be starting right next to the y-axis. This would be our frequency. And we just go up to 6. So however you want to do that. I probably could have gone by 2 boxes equaling 1, but anyway. So we've got 80 to 89 seconds had 6. And you can make your bars kind of wide if you want, because you are going to have to give yourself room to write the numbers. 90 to 99 is going to be right next to it, and that was 5. And then 100 to 109, and that was 2. Okay, so from that then we could say more people finished from 80 to 89 seconds than any other group. We could say there were a lot more that finished between 80 and 99 seconds than there were that finished 100 to 109 seconds. Okay, different ways we could analyze that if they asked us to. Something else we can do for describing histograms is by their shape. So we have 3 different shapes that we're going to be talking about here. One thing is if the bars are about the same height, then that's uniform. Okay, so kind of think about, like, for example, if you're wearing a uniform, you're going to be wearing something pretty similar to what someone else is wearing. In military, that would be probably identical to each other, but we don't have to be exactly identical, but pretty close. So these are all pretty close to the same height as uniform. This one, if you can draw a vertical line where both sides are the same, that's called symmetric. Okay, so if you could like fold it on a line and they would pretty much match up, that's symmetric. And then another one is we have one peak that's not in the center. So like the highest bar here is not in the center, it's kind of over to the side. That's called skewed. It's skewed towards the higher numbers. So problem 3, they're just asking us which one of these does this match up with. So problem 3, part A, you can maybe see if we draw a line in the middle there, that would be symmetric. It's like a mirror image. On part B, we've got our highest bar over to the right, so that would be skewed. On number 3, we don't really have time to go through all of that, but if you did The graph for number 3 doesn't start at 0, so we'd have a break there again. This is what our graph would look like for that one. And this is a little bit of a judgment call. This doesn't really fit real great into all of them, but probably uniform would be the best we could say. This last bar is a little bit lower than the others, but for the most part they're pretty similar to each other. And then the last part there, part B, says how much money should Jay plan to bring for lunch next week. These are ranges 1 to 5, 6 to 10, and 11 to 15. So you know, you could say maybe about for the week, this is how much he spent the last 2 weeks. Okay, it's a little confusing. This is supposed to be saying this is how much he's spending per day, I think. Anyway, so they're saying maybe about $70 for the week. If he's about $10 per day, $70 for the week if we're doing all 7 days. They didn't give real great details about what was going on with that one. So this gives you an idea of how to work with frequency tables and histograms. Have a good day.